Hi guys, welcome to the post-contest discussion of the Codechef Starters 150. This is TLE Eliminators and I am Abhinav Kumar. Let's get started with the first problem of today. So in the first problem, this is find multi-set state. The the heading of the problem only gives us a hint about the solution of the problem in which multi-set is mentioned. Okay, but anyways, let's read the problem. You are given an array A of length n with integer key, and it is known that A is sorted in non-decreasing order. That is, uh, so basically you are given a sorted array of length n. Along with that, you are also given an integer k. Now, what you need to do, you need to perform some steps of operation k times. What you need to do is find the minimum min a. It means the minimum element of the array a. Let's say it is x. The maximum element of array a. Let's say it is y, the minimum maximum, then delete x and y from A. If there are multiple occurrences, delete only one occurrence of x and y, and then append the x plus y, the sum of x and y, to the back of A. So note that after this, the length of A will have decreased by 1. So for example, if you have this array as your initial array, then after the first operation, 3 is your maximum element, 1 is your minimum element. So you would remove one occurrence of 1 and one occurrence of 3. It would have 1 and 2 remaining. Then 1 plus 3 is 4. That would be appended at the end. So the array would become 1, 2, 4. So that's what you need to do in every operation. You need to repeat this thing k times. And then you just need to print the final array after all k operations have been performed. Okay. So you are given that k and a and n are up to 105. So like let's say let's pick this first example. Okay, so you are given this array of length 4 and you are given k equal to 1. So what does that mean? You need to apply one operation on this array. What would happen when you apply one operation? You already saw the example. The minimum element is 1, maximum is 3. Both of them would get removed. It would have 1 and 2 remaining, and 1 plus 3 is 4. So 4 would also get added. So basically, this is how your array would be going. So you need to do this k times, and your k is up to 105. Your length of the array is up to 105. So if you do every operation, if you just create a new array for every operation by removing minimum maximum, that would take O of n time for every operation. And along with that, you are doing that k times, that would take n into k. It won't be accepted. But if you can remove this O of n and instead do every operation in O of 1, then maybe you can solve this question. So what you need to do, if you use a vector, basically if you use a normal array, then to remove the first element, if you remove the first element in the array, that erase would take O of n time. But instead, if you want to do it faster, either O of n or as given in the hint of the problem, in the name of the problem only, it was written multi-set. So basically you can get that you can use a multi-set here. So in a multi-set, you can erase and insert things in O of log n time. So if you can erase and insert in O of log n time, your overall complexity would be k into log n, and that would be fine. So you basically need to just use a multi-set. As you can see, your array would always be in sorted array. If you remove the first and last element and uh, append the sum of them, that would be obviously greater than the larger element. So that would always be the greatest. So if you remove 1 and 4 again, its sum would be 5. That would be greater than uh, that. So always it would be in sorted order, and in a multi-set also it's always in sorted order. So instead of using a vector, if you store the input array in a multi-set, then you can just erase the first element, erase the last element, and insert the sum of them at the end. You can do all this in log n time with an overall complexity of k into log n. So I think this is a very basic problem, basic implementation of multiset. So I think we can directly move to the code. Uh, Audio is sorry, like Is my voice not fully clearly audible? Sorry, just a second. If there is audio issues, let me just check.
It is audible.
It is audible now, right? I think.
Yes, yes.
Okay. Okay, fine then. Maybe there would be some network issue in the middle. Okay, I think the first problem is clear. No need of any more explanation. We can jump to the code. It's a direct implementation of multiset. Just store the initial array in a multiset. I have taken a multiset ms, and then I'm just taking this n times the whole array and inserting all the elements into a multiset, and then I have to perform the operation k times. So I'm running a loop k times. Inside that, I would store the sum. That would be the sum of the first element of the multiset, that is ms dot begin star, and the last element of the multiset is ms dot r begin. Through that, we can get the last element. The sum of them would be stored in a variable sum that would be inserted, and we need to erase this beginning element and the end element. So ms dot erase dot begin, and to erase the end element, it's ms previous of ms dot end. I hope if you know about the iterators in multiset, it would be clear. So we erased the first and last element of the multiset and we inserted the sum of them. So we did that k times, and whatever we got at the end, we printed that. So a very basic problem. Can we use? Yeah, you can also use a DQ here. Yeah, with a DQ, you can actually do in O of n only. There you can erase the first and last element and push back the sum of them. Yeah, you can use a DQ. In that, the time complexity would be O of n, O of k only, k plus n, you can say. Here it's inside this insertion and all is taking log n time, and the overall time complexity is O of k into log n. Okay, so I think everything is fine now. We can start. Okay. Okay, cool. So, okay, let's look at this second problem, which is the easy version of this problem. We'll look at the hard version after this. So here, what we are given is, you are given an array A containing non-negative integers, and we define FA as follows. So you are given an array which has non-negative integers. Uh, we are given an array A which has non-negative integers. And in that, what we need to do is for each index I such that AI is equal to 0, replace AI by an arbitrary positive integer of your choice. So whichever element is 0, that can be replaced by any positive integer of your choice. And for the other values which are non-zero, which are positive integers, they would remain as it is. And then you need to calculate the number of pairs such that I less than j and ai is equal to aj. Basically, the number of pairs of indices so that ai is equal to aj, that you need to calculate pairs of distinct indices containing the same value. That is called p. And now FA is defined as the maximum possible value of P if you choose the replacement of zeros appropriately. So the replacement of zeros can be in different ways. So depending on what replacement you choose, your value of P would be different. Now you need to select the replacement of zeros with the positive integer in such a way so that you maximize this P. If you can maximize this P, the maximum value you can get is called FA. And for the array A, you need to find out this FA. Now, if we look at this second test case, okay, so here we are given this array. Now it has two zeros. It means we can replace these zeros by some positive integer. Now let's suppose you replace these. Let's suppose you replace those zeros by 3. Okay. Now if you replace them by 3, now what would my p, the value of my p be? The value of my P is the number of indices ij such that I is less than j and ai is equal to aj. This is the condition. Number of pairs of such ij. Basically, we need to find number of pairs of indices so that their values are equal. And I is less than j just to ensure if I'm taking, let's say, this is zero based indexing. If I'm taking I equal to 0 and j equal to 1, so it means I'm referring to this pair. Now, if I take I equal to 1 and j equal to 0, that would also refer to this pair only, but we won't count them as 2 because we are given I is less than j. So this pair would be counted as 1 only. This would be valid. This would be valid. Okay. So that's why this condition is given. Otherwise, we only need to find such pair of indices so that their values are equal. Now here, how many such pairs exist? This 1 and 1, this is one pair. This 3 and 3, this is one pair. Other than that, there are no such pairs. So value of p would be 2 here. Now, here we replace those zeros with 3. So my value of p was 2. We need to maximize this value. So my replacements would be such so that I can maximize this value. Let's suppose I replace them with 2. Let's suppose I replace both the zeros by 2 and 2. Now, what would my value of p be? It would be this is one pair, this is one pair, this is another pair, and this is another pair. You can see here 1, 2, 3, and 4. There are 4 pair of indices who have equal values. So here my value of p would be 4. Now, can we increase it further? So if we have, if we replace these zeros by 1, then we would have 1, 1, 2, 1, 1. There you can see how many pairs would exist. Now you would have got a feel that like here there are 4 ones. How many pairs of indices can you select among 4 so that how many different pairs basically you can select from 4? So you can select this pair, you can select this, this pair, or this pair. So if you see, there are actually among 4, you need to select any 2. So 4C2 number of pairs you can have from 4 numbers. So 4C2 is 6. So here there would be 6 pairs. So that this is 1, 2, 3, 4, 5, and 6. These 6 pairs would exist so that AI and AJ are equal. And for this 2, there are no pairing with any other 2. So this would not be included in any of the pairs. So here you can see my value of P was 6. So you would have got a feel what we are doing here. So here the maximum value you can obtain was by replacing them by 1, and that value was 6. You can see the answer for my test case was 6. Now, before moving to how we would replace these zeros, with what value we would replace these zeros, let's suppose we have replaced these zeros and we have got an array. How can we calculate P? Let's derive a formula of how can we calculate P. So if you look at this, here we had 1, 1, 2, 2, and 2. If you have an array like this, how can you calculate your P? As I said, your P is basically, if you look at the frequency of every element, 1 is occurring 2 times, 2 is occurring 3 times. So you can create a frequency array like this, and then you can say, since 1 is occurring 2 times, among those 2 ones that we have, how many pairs are there? So I would say 2C2, only one pair is here, this. Among these 3 2's that we have, how many pairs are there? Among 3, you can select, if you select 2, it's 3C2, which is 3. There are 3 pairs, 1, 2, and 3. So if you just calculate the frequency of every element, then from this frequency array, you can just say this frequency C2, this frequency C2. If you just sum up these, you would get 1 plus 3, 4 as the value of your P. So basically just calculate the frequency array, and for every element, if your frequency is F, then to the sum, just add sum plus equal to FC2. What is FC2? It is F into F minus 1 by 2. So for every frequency, just add this F into F minus 1 by 2 and sum them up. You would get the value of P. Now, this is the way to calculate P. Now, you know mathematically how you can calculate P. Now, what replacement you should do so that you can maximize this overall P? So if you look at this example, here what you had, here you had 1 1 2 and then 0 0. So there would be, now when you replace these zeros, they would contribute to the frequency of some element. If you replace them by 1, they would contribute to the frequency of 1. If you replace them by 2, it would contribute to the frequency of 2. So before replacing them, if you look at this, the frequency of 1 is 2 and frequency of 2 is 1. Now here if you just ignore these zeros, my answer would be, from this 2 you would obtain 2 into 1 by 2, which would be 2, and from this one it would be 0. 1 into 0 by 2. Now where should you add these two frequencies to maximize your answer? If you see, if you add this, if you add a frequency here whose frequency is 2, before you had an answer of 2, if you make this 2 to 3, now 3 into 2 by 2 would be 3. You incremented from 2 to 3. Now had you replaced this, now let's say you have incremented this, you made it 3, and then, sorry, it was 1. 2 into 1 by 2, it was 1. Before it was 1. Now from 1, you incremented it to 3. If you look at this, instead of replacing this, if you replaced this 0 with 2 and increase the frequency of 2 to 2, then before your answer was 0 from here, now it is 2 into 1 by 2, which is 1. So you incremented from 0 to 1. Here you got a plus 1, here you got a plus 2. Now you can realize that it would be always best to add these frequencies to the maximum frequency to get the maximum answer as your overall answer, because your answer is the summation of some f1 into f1 minus 1 by 2 plus some f2 into f2 minus 1 by 2, like this. Now among these f1 f2 f3, whichever is the maximum, if you increase that, that would give you the maximum benefit, because there you can see it's a multiplication. If your f frequency is 3, if you go from 3 to 4, like you can see, for 1 it would be 0, for 2, 2 into 1 by 2, it would be 1, for 3 it would be 3c2 is 3, 4c2 is 6, 5c2 is 10, like this. If you see here, there is an increment of plus 1, plus 2, plus 3, plus 4. So greater the value, greater would be the increment if you increase this. So basically what you need to do is just find whichever element has the maximum frequency, replace all the zeros by that element. Here 1 had the maximum frequency, so we replace all the zeros by 1 and then calculate your final answer. That would give you the best possible P, the maximum P you can get. So I hope the logic is clear. Why we are doing this is just calculate the frequency for every element other than 0. Whichever element has the maximum frequency, replace all the zeros by that element and then calculate your P. That would be the maximum P you can get. So I hope now for the code, what you can do is just calculate the frequency of every element. Okay, let's move to the code. So what I did is I stored a frequency array. I was given that every element was at max up to n. So I created a vector having indexes up to n and initial frequency is 0. Now for every element ai, I incremented the frequency of ai by 1 plus plus. So in this frequency array, I have stored the frequency of every element from 0 up to n. Now for all the values other than 0, they would contribute to my sum. So for I 1 to n, my sum plus equal to frequency of I into frequency of I minus 1 by 2. So frequency IC2, FC2, I did that. I added that to my sum. And in a max variable, I calculated the maximum frequency. Through this, I am calculating the maximum frequency. Now in this, what I would do, this C0 is the frequency of 0. So here, if you see, when I had 1, 1, 2, 0, 0, Here my frequency of 1 was 2, frequency of 2 was 1, frequency of 0 was 2. So initially I calculated my answer from this. It was from this I got 2 into 1 by 2 plus 1 into 0 by 2, which I got as 1. Now, when I replace these zeros by 1, this 2 frequency would get added here. So now I have frequency of 1 as 4, frequency of 2 as 1. So basically from this, if you see, this 2 is replaced by 4. That's what is happening. So the maximum, this maximum frequency is replaced by mx plus frequency of 0. So instead of this 2c2, I would remove this and add 4c2. So this 6 plus 0 would give me 6 as my final answer. So basically, I would subtract this maximum frequency, the value I get from maximum frequency mxc2, and add c0 plus mxc2. So this value is added and this value is subtracted. So basically, I have incremented the frequency of mx to mx plus c0. I have added the frequency of c0 to mx. So removed this value and added this value. So my sum is now updated. So this would be my final answer. I hope the logic is clear for this easy version of the problem. So now we can move to the harder version of the this problem where there is something extra. So now in the harder version, what we are given is again the starting statements are the same, that you are given an array A having non-negative integers and FA is defined. This is the same. For an array A, FA is defined as the maximum possible P you can get by replacing all the zeros by some values. Now, what you are given here is you have an array of size initial. So here your initial array is filled with all zeros, and one by one the entries for the array are coming in the form of n events. So in every event you would say the value at index x ax is y. So you would say the value at index x is y. You would replace ax by y, and after every event, once you have done this first replacement, what is the value of fa now? After the second event, what is the value of fa now? You have to answer this question for every after every event. So one by one you have to answer n times basically. So like if you look at the first test case, I would explain more clearly what you need to do basically here. So this T was test case. Okay, so here you are given this value of n as 4. Now this 4 just means that your initial array is of size 4 initially filled with all zeros. That's what it means. Now one by one you are giving it values. So you would have to answer for every query. Basically, you can say it a query or an event. So after the first event, you would say, let's take this one base indexing. And after the first event, you would say that at index 3, replace the value by 2. So you would replace this value by 2. Now, after this, your array has become this 0, 0, 2, 0. Now, for this array, what is the value of FA? That you have to answer here. Now, if you look at this, now, if you just perform what you did in the previous question for every query. So in the previous question, we were calculating FA in going to every element, calculating your frequency array, and through that doing some calculations. That was O of n time complexity for calculating FA every time. Now you need to do this n times here. If you do this every time you are getting a new array. For the new array, your frequencies would change. For that new frequency, if you again calculate the new frequency array and do this, it would take n times n, O of n square overall time it would take. And here we are given that n is up to 1e5. So this would obviously give you TLE. So you need to find some better optimized way to perform this. So what you can do is, instead of whenever after every query, instead of again calculating your frequency array, if you can just update your previous frequency array according to the new, that single updation, then maybe you can calculate it this in O of 1. So like, okay, before moving to solution, like let's just understand this test case if the problem is not clear to you. So here what is happening after this first replacement, you have this array. Now what you need to do is for this array, what is your FA? FA is basically how can you replace these zeros so that you get the maximum. So here initially you have a 2, so you would replace all these zeros by 2. So you would have 4 times 2, your answer would be 4C2, which is 4 into 3 by 2, 6. So for this test case, for the first, after the first event, you would say the F of this array is 6. Now, after the second replacement, you would replace at index 1 by 1. So this would be replaced by 1. Your array would become 1, 0, 2, 0. So after this second event, this is your array. Now calculate the F value for this array. Now F value for this array, there is a 1, there is a 2. So you can either replace both the zeros by 1 or both the zeros by 2. It would remain the same. After that, you would get the frequency of 1. Let's say you replace them by 1. Frequency of 1 would be 3. Frequency of 2 would be 1. Overall, it would be 3 into 2 by 2. And this would be 1 into 0 by 2. So overall, it would be 3. So for this, your answer is 3. Now you replace the index 4 with 1. This is replaced with 1. So your array becomes 1, 0, 2, 1. For this, what is your answer? If you replace this 0 by 1, it would have again this same values and your answer would again be 3. Now you replace the index 2 with 4. So here your index 2 is replaced with 4. Your array is 1, 4, 2, 1. For this, there is no zeros. So your final answer is obviously whatever the frequencies are. 1 is occurring 2 times. So that would be just a single pair. So your answer is going to be 1 here. So 6331 is the answer for this test case. I think you can see 6331. So I hope the problem is clear. What you need to do is after every step, you would replace a 0 with some value. And then whatever array you get for that, do the same thing that you did for the previous question. Calculate the value of FA for that whole array. Now, if you do the same thing, it would take O of n square time. But how can you do this optimally? How can you do the updations optimally so that you do it in less time? So if you see initially, what is your final answer? Your final answer just depends on your frequency array, the frequency of 0, frequency of 1, frequency of 2. If you know all of them, through that you can calculate your final answer. Now, what would happen when we replace a 0 by some value? What change would occur to your frequency array? Your frequency of 0, this thing, and let's say we replace a 2 by a, we replace a 0 by a 2. So you would have frequency of 1, frequency of 2, frequency of 3. Now, if you replace a 0 by a 2, whatever value you had here, that would decrease by 1, and whatever value you have here, that would increase by 1. That's the change that would occur to your frequency array. And what is the change that would occur to your final answer? Your final answer was basically the summation of the every frequency array minus 1 by 2. And from this, you subtracted the maximum frequency and added the maximum plus frequency of 0. Sorry. So this was your the formula to calculate your final answer. If you look at the previous problem, for every frequencies, just sum up this thing, subtract the maximum frequency and add the maximum plus frequency of 0 to this. This was the formula. Now, if there is a change occurring to these two values, what all terms would change? So if this F2 is increasing by 1, here there would be a term for F2 that would increase by 1. So if the previous value of F2 was F2 and the new value is F2 dash, which is F2 plus 1, then what you would do, you would minus F2 into F2 minus 1 by 2, and you would add F2 plus 1, this thing, into F2 by 2. This is the change that would occur to this part. and what change may occur to these part, you would check if your maximum is changing. If your maximum is changing, replace this thing, and your C0 would be decreasing, so replace these things. Basically, check your previous MX and C0 and likewise just replace these. So this replacement, decrementing the F2, incrementing the F2 value was this change. If you just like look at this formula, it is F2. If you take F2 in common, it is F2 minus 1, uh, minus of this plus of. So basically,
Excuse me, sir.
so these would cancel out by 2. So it is F2 only. Like if this thing you calculate, it would be F2. So if you increase the frequency of F2, you are increasing the overall sum by F2, uh, where F2 is the previous frequency. So like here, if your frequency of 2 was 1 and you replace some other 0 by 2 and your frequency of 2 becomes from 1 to 2, you would add a plus 1 to your sum. So either you can just write this formula only. You can directly write this formula only. No need to derive this equal to F2. Like in my code, I have simplified this thing and written just F2, like Fi basically. So you can directly write this thing. So if you just perform the updation, basically update this part, one of the terms would be updated from this part, and just check if this is getting updated. If your maximum is changing, then update this part and also update this part. So after updating the three parts, your final answer would be updated in O of 1 basically, because there is one term, one term, one term. There are three terms. So there are constant number of terms which you are changing. So it is constant time operation for every query, and there are n queries. So in O of n time, you are basically performing the operations. So I hope the logic is clear. So we can look at the code. So then it would be more clear how I am doing this updation thing. Okay, so here one thing is that initially my array was all zeros. So for my initial array of all zeros, what would my initial answer be? For all zeros, my answer is just replace all these zeros by some value. Okay, so any value. So the frequency of all the zeros, if it is C0, it's C0 into C0 minus 1 by 2. That's your initial answer for all zeros. Then one by one, as the things are getting updated, you would update the answer. So initially, your sum stores your sum stores this part. This part is stored in my variable sum. So this is 0 initially because frequency of all the elements is 0. There are only zeros initially. So this part is 0 that is stored in my sum variable. Then we have this mx variable and mx and c0 that through which we are calculating this part. So we have sum equal to 0. Initially mx is 0. The maximum, there is no frequency, like all the frequencies are 0 for f1, f2, f3, all of them. And my C0 is n. The frequency of 0 is n. There are n times 0 in my initial array. Okay, these are my initial states. My frequency array has all zeros. Now, after every operation, what is happening? I'm taking x and y as input. It just means I'm replacing index x with value y. So I am sure that at index x it was a 0 because I am given that it is guaranteed that for all an event distinct values of x is given. So basically all the distinct indices would occur only one time. So there would be a replacement of 0 by some value. It would not happen that like if your array is this thing, you have already replaced the 0 by 2. Again, you would not get this index again and replace this 2 by 3. That would never happen because x is unique. You are given distinct values of x. So all the indexes are unique. Every index would be replaced only one time. So I am sure I am replacing a 0 by some value. So when I am replacing a 0 by some value, I am storing the initial frequency of that value, frequency of the value that is going to change. This f is storing the initial, the f2 that I showed in my example is the f here. Now I'm updating this frequency of y plus plus. So before updating, I stored the previous value in my f. Now, as I said, sum plus equal to f. You can either write sum plus equal to f, or you can write sum plus equal to this whole thing. Okay, this would evaluate to f basically. That's why I've written sum plus equal to f. If you cannot evaluate this, you can just directly write this because you are replacing this f by f plus 1. Okay, so this is the updation on my sum part, and I'm updating my max by mx equal to max of mx comma frequency of y. So this y, the frequency of this is increasing, so there is a chance this becomes my new maximum frequency. So I would update my mx, and I would decrease the frequency of my c0 by 1. So by doing these three things, I have updated my three states. Now I can write my final answer as this sum. This is the sum plus minus this sum minus this thing plus this thing. So minus mx into mx minus 1 by 2 plus this thing. So this way I'm calculating my answer and C out answer for every case. So you can see these all are O of 1 operations, constant time operations, and this I'm doing n times. So overall time complexity of my code is O of n. So this is very well accepted. So I hope this problem is clear to you. If there are any doubts in this, you can ask in both the easy version and the hard version of this problem. So,
Excuse me, sir. Sir, can you explain the formula once again? How did you come up with the formula?
okay, I hope these both the problems are clear. Now we can move to the next problem, which is replacing game. So in this problem, you are given two strings A and B, both of length n, containing only lowercase English letters. You also have an integer k. So now you're given two strings of length n and an integer k. You can perform the following operation. Choose a continuous substring of A of size exactly k and a character c. Then replace all the characters in the substring with c. So for example, if you have this string and the given value of k is 2, it means you can select any substring of size exactly 2 and replace that whole substring by a character of your choice. So if you selected I equal to 2, it means it refers to this substring from I equal to 2 and 3, length 2. So this nt is replaced by a character of your choice. If you choose the character p, it would be replaced by p and p, and it would become appear. Okay, n and t are replaced by p and p, rest remains the same. Or maybe if you select I equal to 5, so 1, 2, 3, 4, 5, then your substring would be this AR. So, and you select the character R, this AR would be replaced by R and R. It would become this. Okay, I hope the operation is clear. Now, check whether it's possible to make A equal to B through a series of such transformations. If it is possible, also output a list of transformations of size at most 2n, 2 times n. So basically what you need to do, you are given two strings A and B, you need to perform these type of transformations to A, and you need to find if you can, by performing these transformations, if you can transform this string A to be equal to this string B. If you can make the string A equal to B by using these transformations on A. If not, you would print a -1, I think, if you cannot do it. And if you can do it, you need to print the series of operations. What all operations you would perform, you need to print all of them. So that's the problem. Let's take the first, let's take some example to understand it more clearly. Let's take this last example. Okay, you are given these two strings. This is string A, this is string B. Now you need to make this, you need to transform this A so such that this, after transformation, this A becomes equal to B. Now what all transformations you can do is basically you can replace any substring of length 2. This k is given as 2. It means you can replace, you can pick any substring of length exactly 2 and replace all the characters in that substring by
any character of your choice. So if you select this substring AB, and what you need to obtain, you need to obtain this. So one way of doing it is select this substring, replace both of them by P. So it becomes PPCD. Then you need to have QQ here. So select this substring of length 2 and replace them by Q and Q. So it would become PPQQ. So this way, by doing these two transformations, you can obtain this. So how would you answer? How you have to output your answer is, if you are performing this transformation on this substring, the starting index of the substring is on one based indexing. It is 1. So you would print 1 and the character you are replacing with, you are replacing by P. So 1P represents that you will start from 1, take a substring of length K. So length is 2. So this is the substring you are taking and replace it with the character P. So this operation is denoted by 1P. Now, how would you denote this operation, replacing CD by QQ? So your index for the start of your substring you are choosing is 3. So you would write 3 here, and the character you are replacing is Q. So you would write Q here. So by performing these two operations, and number of times you are performing operation is 2, 1 and 2. So this is the output you have to give for this test case, 2, 1P and 3Q. So I think you can see 2, 1P and 3Q was the output, was one of the way to do this. There may be multiple ways also you are given. You can choose any way. You have to just transform A to B. And one restriction is given, that you can use at most 2n operations here. You cannot use more than 2n transformations. At most 2n transformations can be used here. And it's given that if you cannot do in 2n transformation, that means you just cannot do this. If there is a way to transform A to B, then you can always do them in less than 2n transformations. Otherwise, you would print -1 that you cannot. So I hope the problem statement is clear what we need to do now. So what you can do here is basically, the first thing you need to understand is, okay, the first basic thing that comes to your mind if you look at the test case is, like for the first case where both A and B were already equal, you don't need to perform an operation. So first thing is, if A and B are already equal, then you would just print 0 and return. No need to perform any operation, they are already equal. Now, when A is not equal to B, that is the case you need to solve. That's the problematic thing. Now, if A and B are not equal, that means you would need at least one transformation. Without any transformation, A and B are unequal. You are not changing anything. So it just means that at least one transformation is needed. Definitely. There may be need of more than one transformation. But I'm saying that at least one transformation is always needed. Now, one thing you can observe, that if you need to transform this string, some string A into string B using these transformation, so let's say you use some series of transformations. Like here, if you see, what are like transformations you could have used here? Maybe you could have also done, if you have A, B, C, D, maybe you could have replaced this by a P and P. So A, P, P, D. And then maybe you could have replaced this by P, 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 D, and then replace this by a Q, P, P, Q, Q. This was also a valid way of doing the transformation using 3 transformations. This answer would also be accepted because you don't need to minimize the number of transformations. So you just need to find any way of doing it by any way in less than 2n transformations. So n is 4 here, 8 are too much. In 3, so here you were doing in 2 operations, in 2 transformation. Here you are using 3 steps to do it. This answer is also acceptable. So there can be multiple ways to do this. Now, if you like look at this, what is happening here? You could have directly replaced both this by P, both this by Q. Now, what if you had to obtain, like instead of this Q, there was, let's say, Z here. Okay. Your A was, instead of Q, you had a Z in this test case. Now, can you transform this into this now? Like if you look at this A, B, C, D, ZZ. What you could have done is you could have replaced this by a Q first. So transform this into QQ. Or you could have replaced this by Z first. So what you could have done is replace them by ZZ first. And then, okay, here you can't do, instead of P, let's say, here you can't do it. Instead of taking a Z here, let's say you have a Z here or in the middle. Let's take this example. Your array A is A, B, C, D, E. Your array B is P, P, Z, Q, Q. Okay, let's say you have this example. Here you can see you can always replace your K is 2 here. So first thing you would think that you always have to choose a substring of length 2. So here you have to find a single Z. Now, how can you have a single Z here? So the problematic thing is if you replace a Z, you would always have two Zs that you would replace. But still you can have here because you can transform this into AB. Let's suppose you replace both of them by Z. It would become ZZE. And then you replace both these by Q. So it would become ABZQQ. And then both these by P. It would become PPZQQ. So like this, although you had 2 times P, 2 times Q, those were easy, replace both of them by P, P, Q, Q. But to get this Z, you replace this Z initially only, and then above that you replaced it with a Q. So through that you obtained a single Z. So if your K is if your K is some 4, and there is some string, some character occurring 2 times, CC, which is occurring 2 times, you can still have this by having it 4 times and then replacing these C's by some other value. But you cannot do it always. Like here, if you had string A equal to ABC and string B is equal to PQR, like, and K is 2. Here you can't do this. Like you cannot have a single, if you replace both of them by PP, let's say you replace both of them by then QQ, PPC, then you replace both of them by QQ, it would be PQQ. But you cannot have a R here, you cannot replace single one. So you can never, from this you can never obtain this because all of them are one. So now the problem is, how can you do this? Basically, when would you decide that you can do this and when you can't do this? So the observation that I was telling that you need to observe is there would be at least one operation needed. So let's see, after a series of operations, the final string that you obtain, if you perform at least one operation for the final string, what is one thing you can definitely say? The one thing you can definitely say is that in your final string, whatever string you have, there would be at least one character that would be occurring k times consecutively. There would be some substring of size k where there would be a same characters. Like there would be k consecutive characters, which would be the last operation that you perform. If the last operation you perform was I ch, where ch is a character, I is the index, then from index I up to index I plus k minus 1, here you would have all ch, this character ch would be there. So for sure in your B, you should have at least have one time that some character is occurring k times consecutively. If that is not there, then after doing a series of operations, you can never get to that B. If you look at this B, if you look at this B, here your k was 2 and you have no character that is occurring 2 times consecutively. All the characters are occurring single times. There is no character there is no PP or QQ, something which is occurring consecutively. So you can never form this B after any operation. If you don't do any operation and your A is this only, your A is PQR only, then you would say that yes, in 0 operations you can do that. But that case is already covered. Initially only we would check that if A and B are equal, you would return 0. But once this case is handled, now you for sure you know that A and B are different. And if A and B are different, there would be at least one operation. And if there is at least one operation, and in this final B, there is no character that is occurring k times, you would print -1, that you cannot do. Now, what if there is some character that is occurring at least k times in such type of string? Okay, you have handled the -1 case. Now, in such type of string, now can you always form this? Can you always form this? That's the question. What I'm saying is yes, you can always form this B. Now, how you can do this is, okay, the first thing you found is you found such an index where you had k consecutive characters which are same. Now, once you have done this, you can say whatever A you have initially, okay, you need to replace by what B you have. Okay, let's say, let's take this example on. Okay, here there was one series of P that was occurring 2 times. So here I would say there was two, like this also you can take, this also you can take. There are two characters which are occurring consecutive times, k times consecutively. So for this, I'm saying that yes, an answer would always exist. Now, how can I get to the answer? You also have to print the operations that you can do. Is just take one such. Let's say I'm taking this one. Okay. Let's say I'm taking this consecutive piece to be the my last operation. Okay. So this would be my last operation. The last operation I would perform would be this, replacing the first two indexes by PP. Now, what I can do is I can manage all the other values by the operations before that. If I have to have a Z here, then just before PP, okay. So what I would do, this is the last operation I would do. So if I have to have a Z here, if whatever array I have, I would replace this thing till k with Z, Z, Z. Then I have to have a Q. So I would replace this thing with Q, Q, Q. Then I have to have a Q. So this would remain a Q. So basically, what I can do is, or like one more thing, if this Q was like one more case, there would be when that could be -1, is if instead of this Q, there was some, let's say, S. So although there is a P, but this S cannot be replaced because you need to have one more something here. So for the last, if K is 2, then the last character that should be equal, otherwise you cannot do this, or it should be equal to QQ. So till here you can apply the operations. So what you basically need to do is just find such series of characters. Let's say there is some, let's say with X I'm denoting the characters. So there are some X which is occurring K times, like, sorry. So I'm through this I'm telling this is a general string B. In a general string B, at some index A, I found such an index I, so that from this I there is some character X which is occurring K times here. So this index would be I plus K minus. So from index I up to I plus K minus 1, there is the same character X. So what you can do, this Ix would be my last operation. Before that, for the left ones, what you can do is start doing the operations like this. Start doing the operations, this first, above that this, above that this, above that this. Like this, if you do the operations, then whatever character is here, that would be replaced by this. After that, whatever character is here, that replacement would be this. Whatever character is here, that replacement would be this. And then after that, if these are replaced, in final replacement, they would be replaced by X. For the right side, you would move from this side. Okay, you would move this way. So it would be like this. First, you will start from the end, replace whatever character is here, replace this substring by this. Whatever character is here, replace this substring by this. Whatever character is here, replace it by this. Okay. I hope you have got the intuition of what I'm doing. Let's see an example to understand more clearly. Like if you have an array, do I have some example here? Okay. Let's say you have an array A, B, C, D, E. Whatever this array A is, it does not matter actually, unless this A is equal to B in the initial case. Once you have managed that, then you are just replacing all the characters by something to form B. So this A actually doesn't matter after checking whether it is equal to B or not. So let's say here you have some C, F, P, P, Q, or one more P, Q, R. Okay, 1, 2, 3. Oh, okay, let's say you have this 1, 2, 3, 4, 5, 6, 7, 8. E, F, G, H, I. Okay. Let's say you have this as an input case. So what you would do, and you have k equal to 3 here. Okay, you have k equal to 3. So first you would check whether A and B are equal. They are not equal. Okay, so move ahead. You need to perform at least one operation. Then just check whether there exists some I, so that there is a substring of length at least k where all the characters are the same. So you can find this PPP, a substring of length 3 where all the characters are P. So just mark this thing first. Okay, I'm taking a zero based indexing here. Okay, so this would be the last operation that I would perform. This in zero based it is 2, in one based it would be 3. Okay, in my final answer I would make it one based by adding a plus 1. So now I'm taking zero based only. So this would be the last operation that I would perform, 2p. 2p would be the last operation that I would perform. But before that, what I have to do for the left sides, I would start from the start. I have to have a C. So I would replace the first 3 characters by C. So first k characters by C, C, C. Okay, so my first operation is 0C. This is done. Now in my here I have to have a F. So this would be replaced by F. So these I would replace by F, F, F. So one F would be my next operation that I would perform. So I got a C, I got a F. Now I have here, I got 2P. So this would be performed at the end. Leave it for now. Now start from the end. From the end, what you would do, you need to perform this, you need to have a R at the end. So for this substring, you replace all of them by R, R, R. So for this index, you need to perform for this index 5. So your operation is 5R. That means here for the last 3 values, you are replacing them by R, R, R. Then here again, you have to have R, replace this thing by R. So 4R. 4R would be your next operation. So replace all of these by R, R, R. All these 3 are replaced by R. And then you need to have a Q here. So replace this whole thing by a Q. So this was 3. So next operation would be 3Q. So you replace this whole thing by Q, 3, 4, 5. Your indexes. This is replaced by Q, Q, and Q. Okay. Sorry. It was this is Q, this is Q, and this is Q. So you have it like this. Now at the end, perform this operation, 2P. So just replace, I think this, and this are replaced by P, P, and P. So if you just look at this, what you obtained here is, this is C, this is F, then this was also replaced by P. I think I had an extra. So there would be 3 P's after that. And then you have, okay, the P replacement, I made a mistake. Here it would remain Q, and this was replaced by P. So now C, F, triple P, Q, and then R, and then R again. So I think you would have got what I'm trying to do is just do this thing at the end, and before that, from the start, do it like this. From the end, do it like this. That's what you are doing. Do this at the end. From the start, do it like this. From the end, do it like this. So with this sequence of operations, you can always form the string B you can always form. Yeah, the another case that I said was said mistakenly, because from the right side, you would have to start from the right, and you can do like this. So here where I was telling that like the answer would be -1 only for the case where there are no consecutive characters of length k. If it is not happening, then always you can have your answer. Okay, because from the right side you can do like this and do, and from the left side you can do like this. Okay. Maybe run a code to see how it changes. Like I tried to do this in this example. I think I did it a little messier. Okay, let's look at the code. If you are still not able to get, I'll explain one more example. Okay, let's look at the code for this problem, and then I'll again with an example, I'll explain along with the code. So what I'm doing, I'm taking the input string A and B. I would just check if both the strings are already equal. I would print 0 and return. No need to do anything else. If not, then definitely there is at least one operation. So what my series of operations is going to be, first I would try to find out if there is something, if there is some k consecutive characters which are occurring. So what I'm doing, like this k equal to 1 case was not needed. In the question, it was given that k is greater than 1. So this thing was not needed actually. From here, you can look at the code. So in J, I'm storing that index from where I have k consecutive characters of equal. So initially J is -1. That means I have not found that. I would run a loop. I would in C, I'm storing how I would store that my frequency of the last consecutive what I'm getting. So in C, I'm initialize this variable C with 1. What I'm doing after that is if bi is equal to the previous element C plus plus, if they are unequal, reset C to 1. So whenever I get some equal element, this C would keep on increasing. If I have 4 equal elements, it would increase 3 times and become 4. Then when I get an unequal element, it would again reset to 1. So in this C, always I am getting the updated value of the last, how many elements are consecutive. Once this C becomes equal to K, it means I have K consecutive elements that are equal. Last K elements are equal. So if last K elements are equal, the starting index is I minus K plus 1. So from I minus K plus 1 up till I have this subarray from I minus K plus 1 till I is the subarray that are equal. So this starting index is I minus K plus 1. Once I have found just any one such index, I would break out of the loop. No need to find any more. Okay, break out of the loop. If J remains -1, it means we never found such an index. J was initially -1, it remained -1. We would print -1 as our answer and return. Okay. Other than that, always we would have an answer. So how? So my answer I'm storing in a vector of pair of int comma char. So for every operation is denoted by an integer index and a character, the character that I'm replacing. So in a pair, I'm storing that answer and all the operations are stored in a vector. So this vector of pair, in this I'm storing my complete answer. So how the sequence of my operations should be for all the values before j. So this loop is running from 0 up till less than j. So this is a for loop from 0 to less than j. Let me write it. What? Okay, so this is what was written there. So from 0 till less than j, I am running a loop. And what I am doing is, in my answer, I would push back. This was a 0 based indexing, so I push back I plus 1 because in the answer I have to print in form of 1 based indexing. That's why it's I plus 1, otherwise it would be I only. So start from I and take the character bi. Bi is the character that I would replace. This is for the left side. Now for the right side, I'm running a reverse loop. So this is actually, I would replace, and so what? This is a reverse loop from n minus 1 to j plus k. Okay, so this is what it is. So I'm running a reverse loop starting from the last index. Also, yeah. So starting from the last index up to j plus k. So j plus k is the right end of the after which my those k consecutive elements are ending. So from last index up till j plus k, I have to, this is the right part. So that I have to replace. So I would push back in my answer. Uh, in the what I have to output is the starting index of my subarray. So this I is the end index of my subarray. So starting index would be I minus k plus 1 and then a plus 1 extra. So this is the starting index and a plus 1 extra for the converting from 0 base to 1 base. So this is what I'm storing. This is what I'm storing in my answer, and bi is the character. So this is handled for the right side, and then for the middle part from j up, I would replace them with bj, these k consecutive characters. So through this, I'm storing my answer. Then I would just print the size of my answer, and for I would iterate through my answer and print I and the character. So I think the code is clear. So let's, the test case that I explained there, let's see that only more clearly. A, B, C, D, E, F, G. If it is not clear to, let's dry run that quickly. So what I'm doing, what I'm taking here is, in A, I'm taking A, B, C, D, E, F, G. And in B, I'm taking what I had here is C, F, triple P, and Q, R, R. C, F, triple P, and Q, R, R. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6. Okay, I had to add H here. So this is the test case I am taking. So first I would check if A and B are equal, they are not equal. Then through this, I am just checking whether they are k consecutive elements. Here my k is 3. So for that, this is the place where I found there are 3 consecutive p's. So here I would, in C, in J, what the index I would get would be the index of this P, which is 0, 1, 2. So 2 is the index I would get. From this index 2, we have 3 consecutive characters which are equal. After that, since this J is not -1, if it would have been -1, we put -1, we didn't find any K consecutive equal characters. Now, once we have found this, now I would initialize this my answer vector. And then for the left part of this, for C and F, I would run a loop. I would first replace, I would first try to get a C here. To get a C here, I can always do an operation of length 3. So I would replace the first 3 characters by C. So I would replace them by C, C, C. This would be my first operation that I would do on my index, first index. So I would start with 0, and at I equal to 0, I replace, so in one base with indexing, it would be 1, replace it with BI. B0 was C. So the first 3 characters are replaced with C. After that, the next character is F. So I will replace these 3 with F, F, F. This would be my next operation. So I, at index I, the next 3 characters are replaced by F. So again, so this would be handled here. Once I am done here, before P, this CF is handled. Now, after these P, I have to handle the right side. For the right side, I would replace the last 3 characters with this R. I have to get an R at the end. So I would replace these last 3 characters with R, R, R. So this last index was n minus 1. Like if this is I is the last index, then I minus 1, I minus 2. So for k equal to 3, I minus 2 is the starting index. That is I minus k plus 1 is the starting index, and plus 1 for converting into one base indexing. So this is the starting index of the subarray that I am replacing. Replaced with bi, replaced with this character. Okay, so this is the first operation. Then I have to get a R here. Although I already have a R here, but I'm doing again this, I'm doing a general operation. So in my loop, again, they would be replaced by RRR. So these 3 characters are replaced by RRR. After that, I have a Q here. So these 3 characters would be replaced by a Q. So Q, Q, Q would be replaced here. So once I'm done with the right side, left side CF is done, right side QRR is done. Once both of these sides are done, then I would just do the middle part for the J part. So here you I have to get the 3 P's. So these 3 would be replaced by P, P, P. So this A is now equal to B. I have obtained this. Okay, I hope now After this dry run, the code is clear and everything is clear. Okay. So I think this problem is clear. We can move to the next problem now. Okay, min ops, this easy and hard version. So for this problem, what I'm going to do is directly explain you the hard version. I'll tell you for the easy version what brute force approach you can do, but I've written the code only for the hard version, which is accepted for both the versions. So only the constraints are changing in both the easy and hard version. So we'll cover both of them together. Okay, let's look at the problem first. Constraints are afterward. Problem is the same for both the versions. So let's look at the problem. We are given an array B of length M. And in this array B, you can perform these operations. Select L and R. So basically what these things means is, in the sentence it is given that for the array, just choose a range of equal values in the array B or array A. So this L and R is a range of equal values, and that's the maximal. So it means you cannot extend this range further by taking the left or right ones. So if you have some array, okay, if you have this array, then either you can select this subarray, all the ones. If you select this one, you can extend this range by selecting this one. So that would not be valid. This L2R range is valid. So take all of the ones that are consecutive, or just take all of the threes are that are consecutive. These are the ranges that you can select. Let's say you selected this range. After that, after selecting a range, what you can do for the whole range, you can just decrement all the values or increment all the values. Just modify bj to bj plus 1 or bj to bj minus 1. So either decrement all the values together or increment all the values together. So that's the operation you can do. So this is a single operation that you can do on the array. After that, what it is asked here, for an integer k, we define fbk to be the minimum number of operations required to ensure that the sum of adjacent differences of b doesn't exceed k. So here there is a function defined fbk. So for the array b, if you are given a k, then fbk denotes that if you compute the sum of differences between the adjacent elements, then the sum of differences should become less than k in minimum number of operations. So initially, if they are more than k, you need to apply some operations and get this sum of differences between the adjacent elements to be less than k after applying some number of operations. And you need to do this in minimum number of operations. That would be the value of your fbk. So if that is clear, then you are given an array A of length n, and then you have to answer q queries. So these are the things, information you are given. Then in the question, what you need to do is, for the array A, you need to answer q queries. Every query you are given L and R, a range, and a k. So you need to find the value of, take the subarray from L to R as your array and this k as your k, and find the value of the function. So basically, for the subarray from L to R, if that is the array, then what is the value of your function? What is the minimum number of operations to reduce this sum to be less than equal to k? That's what you need to find. You need to answer for every query, and you have q queries here. Okay, so let's look at the first test case to just understand what you need to do. So here what you are given is, I think this is not included. So you have n and k, n and q. So q queries. Okay, you have n and q. So this is the array, and these are the q queries. Okay, so you are given this array 164. Let's say this is your initial array. Now, after every query, in every query, you have to answer. In the first query, the range is given 1, 3. Okay, let's index them. So for the subarray from 1 to 3, it means the full array. So for this full array, if the value of k is 1, if the k is 1, then find the minimum number of operations to reduce the sum of differences between adjacent element to be less than k. So what you need to reduce is here that summation of ai minus 1, this thing. This is the thing that you need to reduce to be less than equal to k. What is this for this array? It is basically this difference is 5, this difference is 2. So 2 plus 5 is 7. So 7 is the sum of differences between the adjacent elements. Now it is 7 here. Okay, 5 2, it is 7 here. You need to reduce this 7 to 1. You need to have this value less than equal to 1 by performing some operations. So what operation? So what is the minimum number of operations you need to perform so that you can reduce this to 1? That would be the answer for this query. Now same thing, that would be the answer for this query. Same thing you need to do for the next query. Here for the same range, the value of k is 4. So if k is 4, for reducing it to be less than equal to 4, what's the minimum operations? Here it is 8. Now for 1 2, now when your range is given 1 to 2, it means you have to consider only this array 1 and 6. For this array with k equal to 2, what's your minimum number of operations to reduce it? Okay, so like for the before like solving this problem, let's say if you, instead of giving you a range, if you are given an array. Okay, so for every query you would get an array. That sub array can be considered as an array. So if you have an array A and a k, what's the value of this function? What's the minimum number of operations you can do? How can you calculate this optimal? Let's try to figure this out. So first thing is, how do you perform the operations? That's the first thing. So what is the thing you need to minimize is the difference between two. So let's say you have some array like this. Okay, if this is the array, 3, and then let's say you have another one. Okay, if this is the array, what is the thing that you are trying to minimize? Is the sum of differences. So sum of differences for 1 1 where it is equal, it would be 0. Here you would have a 1. Here again it would be 0 0. Here you would have a 1. Here you would have a 2. So your sum of differences is this thing, 1 plus 1 plus 2 4. Now how are you calculating? Like in these part where they were equal, what I said is its difference would be 0. So if you consider it or not, it's the same thing. So basically you need to find only for different values. And how are you performing the operations? After performing the operation, let's say its value is 4, how can you reduce it? Now for the operations, you can always pick this as a range, or this as a range, or this as a range, or this as a range. You cannot pick a mixed range where there are two values, or you cannot pick a sort range if you can extend it here by having the same value. You cannot pick this. So the range you need to pick is either this or this or this or this. So is there a need of keeping this three times? It's same as having it one time. So first thing is just compress this array. It would be the same thing. No change in the type of operation you are performing, no change in the value that you are calculating. So reduce this 2 times 1 to a single time 1, this 3 times 2 to a single time 2, this 3 to 3, 1 to 1. So first thing is compress the array. Whenever you have some consecutive same values, compress them to a single value of that type. So there are no values. So all the adjacent elements are distinct now. So compress this array such that all the adjacent elements are distinct. That's the step 1. Because by changing this, you are not changing anything to your answer. Now, how would you find the, now what all operations you can do is, here your basically difference was 1, 1 and 2. Now what all operation you can do? You can maybe increment this 2 to 3. So this would reduce to 0, but this would in turn increase to 2. Okay, so this is not giving you any benefit. Maybe you can reduce this 3 to 2. Okay, then what would happen if you reduce this 3 to 2? This difference would become 0 and this difference would become 1. So if you reduce this 3 to 2, it would become 0, it would become 1. You are reducing your answer from 4 to 2. So you are decreasing this answer by performing this operation. So this is a good operation that you can do. After this, what you can do is, if you want to reduce your answer further from 2, if you reduce this 2 to 1, you are basically not changing anything. This would get reduced to 2, but this would in turn increase to 1. So what you can do is, you can increase this 1 to 2. After this 1 can be increased to 2 to make it 0. This 1 can be increased to 2 to make it 0. So in total 3 operations you made from 4 to 2, then 2 to 1 by this operation, and 1 to 0 by this operation. So in general, if you see, like if you try to imagine the values on a number line, let's draw a like type of a graph. Okay. So in the array, these are the in the x-axis, I am showing the indexes, and this is the value. So my array was, at index 0, I had a 1. At index 1, I had a 2, 1, 2, 3, 1. So 1, then a 2, then a 3, then again a 1. So I had my array something like this. Okay. So your array would be like something like this only. Something like this. Okay. Something, it would be your array. So how can you reduce the difference if you look at it? If you have, what's your difference? This is a 1. This difference is a 1. This difference is a 2. So it is 1 plus 1 plus 2. This is the sum of differences that you need to reduce. So if you reduce this maxima point here, if you reduce this maxima point to here, your difference is automatically reducing. This plus 1 and this plus 1 is decreasing. You are reducing by your final answer by 2. Okay. And let's say, so like in general, you can just imagine, if you have some graph, yeah, that was the only case. If you have something like this, it would be something like this. Okay. So wherever you have some maxima point, reduce that. Okay. So whatever that would be, this plus 1 and this plus 1, you would do a -2 to your answer. Okay. So if the points were this, if it was plus x and if this was plus y, by reducing this point by 1, it is now x plus x minus 1, and this thing is now y minus 1. So you have reduced your answer by 2. And for any minima point also, the same thing, if you increase it. So if the points were like this, okay, if the points were like this, if this height was x and this height was y, you increase it by 1. This height is now x minus 1. This height is now y minus 1. So basically, you can say, for any maxima or minima point, if you reduce the maxima point or increment the minima point, you can reduce your final difference by 2. Now, with every step, if you are reducing by 2, so that's one thing. Now, when it would happen that you cannot reduce by 2, it would only happen when there are no maxima or minima point. That means your graph is something like this, either increasing or decreasing. Once that happens, all the maxima and minima points are, like, you can imagine, when you are reducing this, you are just compressing the points. Okay. Let's leave that. Okay, like when you are, if you see here, when you have some graph, if you are reducing this maxima point, basically you are compressing it to be something like this. If you reduce it again, you are compressing this. After some time, this maxima would disappear. Same way, if you reduce this maxima would disappear. Or if you increase this minima point, it would disappear. So after increasing and decreasing the maxima and minima point, after some time, the graph would become either increasing or decreasing, completely increasing or decreasing with no maximum. After this, if you have something like this, like in the above case, when you had 1, 2, 3, and then a 1, when you reduce this 3 to 2, and then this these were also reduced, or you can say there was no maxima point here. Okay, so once something like this happens when there is no maxima point, okay, it would be like something like this, increasing. Like you cannot say this is a maxima point because this is equal here and this is less. So something like this can also happen. Okay, once something like this happens, then you can only, in one operation, you can only reduce your difference by one, is by increasing the endpoints, increasing or decreasing the endpoints. By increasing the decrease or decreasing the endpoints, you can increase your or decrease your answer by one. Okay, so this is the thing that you need, you had to notice basically in this problem is until and unless there are some maxima point, you can reduce your difference by 2. After the graph is something where there are no maxima minima point, you can reduce, you can go on a steps of 1 only. So if your k is some k and initial for your initial array, your difference is, let's say, d, that means you need to go from d to k. So d minus k is the reduction that you need to do. So this reduction, if this k is greater than, or like if you can do all the reductions through maxima and minima point, you would say in k d minus k by 2 steps, in d minus k by 2 operations, you can do it. But if maxima and minimum points are over, then some steps you would do -2 -2, after that you would do -1. Okay, so that's one thing. And when the maxima and minima points would get over, is that also you can realize is, if you see the graph, your starting and ending point would always remain the same. Like if you are changing the maxima and minima point, if you are reducing this, your starting and ending point would never be a maxima or minima point. They would never be changed. So once all the maxima and minima points are over, the graph would be something like this, starting from here, ending in here. So what would be the sum of differences for this graph? When there are no maxima or minima points, so once it is increasing, it would never reduce and then increase. So if that is never happening, that means this minus this, the difference between the starting points, is the sum of differences for this array. So this is your resultant sum of differences where you can reach. So till here you can reach with steps of 2. After that, if you need to reduce the distance, you would either reduce this or increase this with steps of 1. So I know a little bit maybe complicated to understand this. That's why I tried to visualize you this thing through this graph. Like in my mind also, while thinking about this problem, I visualize it like this only. Whenever you have some, you are given some values and you need to do some increment decrement thing, always try to like visualize them in the form of some graph, what you can do from that graph. And the thing that you had to calculate was the differences. So whenever you have a graph something like this, your sum of differences was this thing plus this thing because of the reduction, then plus this thing, then this thing. So whenever you are reducing and increasing, this double time it is getting added. So when they are over, it would be a single time. So if you feel it like this, you would be able to understand this. Okay, tougher to implement. Yeah, if you have thought about thought this intuition and the logic that I'm telling, now we would see the code also. It is not too tough to implement. It is easier only. Okay, like more things that we need to clear. So I think this thing is clear what you need to do. So okay, what you needed to answer here was for every range from L to R. So here, this is how we calculate our function. So for our function, what you need to do is, okay, I'll write the things that you need to do. If you are given an array A and a K, okay, for this array A, let's say this is 0 and this is n. The starting is 0 and a n minus 1 is the ending value. So first compute for this array the initial sum of differences. Okay, just one by one go to every element, compute the differences. Let's say that initially your sum of differences is d. Now you need to reduce this d to k. Okay, this d is initially greater than k. If d is less than k, then in zero operations you can do. Okay, no problem. If d is less than equal to k. Only for the case when d is greater than k, when your initial sum of difference is greater than k, then you need to reduce this d to k. Now first you would check so when you are moving in steps of 2 until where? Until where is the difference between the starting and ending value, as I said. Once it becomes monotonic, this would be your difference. This would be your D where you would reach. So till let's define this difference as the difference between an minus 1 and AC, the absolute difference. So D is here. Below that either diff is there and then k is there. So there can be two cases. One when k is greater than equal to diff, or when k is less than diff. Okay. So for this thing, your d is here, k is here, difference is here. So to reduce from d to k, you are always moving in steps of 2. So your final answer would be just d minus k by 2, the seal of this. That would your final answer would be when k is greater than difference. So you can always move in steps of 2. When you have to go below this difference, below this, then till this you would move in steps of 2. So d minus diff, till here you would move in steps of 2, and after this for diff minus k you would move in steps of 1. So this would be your answer for this else case. So you can just divide it in two parts. Once you have calculated this d, k and diff through this if else and this formula, you can write your final answer. Okay. Now the problem is to calculate this difference or this d, your initial d. To calculate this initial d, you would have to go to every element. Now you are given a range from L to R. You know the starting and ending values. Now for the whole range, the sum of this differences, if you go to the whole range, then for the easier version, it is okay. But for the harder version, if you see, your constraints are n is 2e5 and q is 2e5. So for the harder version, for every query, if you are taking O of n time to calculate this difference for every array, for every range, then O of n into q would give you TLE for the harder version. For easier version, that would be okay. For easier version, you can do that. So for the harder version, that would give you TLE. So how can you compute for a range the difference? So you would have got an intuition for this. You can use a prefix array simply. So you can pre-compute your differences for the whole array. Okay. You can pre-compute your sum of prefix sum of like basically sum of differences, the prefix sum of differences for the whole array. And then when you are given a range L to R, you can say for this range, your difference is prefix sum from R minus PR of, it is L minus 1 generally. But here, if you write L minus 1, let's say this is L and this is R. So in L, this difference from L minus 1 and L is also included. But if you are taking this array, this L minus 1 is not there. So this difference you don't need to include. So you can just basically exclude this thing. Okay, so instead of writing prefix L minus 1, you would write prefix L only simply. Okay, so your prefix array, you are, okay, like I'll show you in the code how I'm computing it. So in O of 1 only, once you have pre-computed your prefix array, you can write your difference like this. Once you have computed your difference, you can write your, sorry, this was D in my above notation. The D I was talking about was this. Okay. So D you can calculate as prefix of R minus prefix of L, this summation thing. And then the difference is basically, this is O of 1 operations, A of R minus A of L. This thing would be your diff, and your K is given to you. Once you have calculated diff, K and these things in O of 1, you can write this if else. So I hope the Are you taking the max of the left and right minima from the maxima for the difference? For this difference, I think you're talking about this difference. The point after which we would move in steps of one would be, okay, like I'll explain from the code, I think. If you didn't get, let's look at the code, and then if you still have a doubt, you'll tell. Okay, let's look at the code, and then I'll again explain if you still have a doubt. So, yeah, this is the code. Basically, what I am doing here is I'm taking this array input, and in my prefix sum, what I'm computing is this prefix sum is storing the prefix sum of differences between the consecutive elements, this thing. So prefix of I is storing the sum of differences up till I. So AI minus 1 is the current difference plus the previous this. So this is how I'm calculating the prefix sum. So for example, if my array is this, if my array was 164, so 0, 1, 2, my PR of 0 would be 0 only. PR of 1 would be this difference, which is 5. Okay. And my PR of 2 would be 5 plus this difference 2, which is 7. It would store 7. So likewise, in PR of 2, I'm storing this difference plus this difference. Okay. If I had more elements in PR of I, I'm storing this difference plus this, like this. The sum of all these differences is stored in PR of I. Okay. I hope you got it now. So to compute the sum of differences for a range from L to R, what I can do is, if this is my L, this is my R. So PR of R is storing the sum of differences for this whole range, minus PR of L is these differences. If you subtract, then these are the differences that you need. So PR of R minus PR of L would give you the sum of differences for the sub array from L to R. Okay. I hope it is clear now how I am computing my prefix array and how I am using it. So now for every query, what I would do, the query is from LRK. I took the input. I converted to a zero based. In my query, I was given L and R as one based indexing. Here I'm calculating my prefix sum as zero based index. So I did L minus minus and R minus minus to convert it into a zero based indexing. And then my sum is like the sum of difference that I was talking about is prefix R minus prefix L. Then this div that I have written is the difference between the AR minus AL, the starting and the ending points. Okay. So if I have something, my array like this is my LF position. This is, so this graph represents my subarray from L to R. So after some steps where there are no maxima and minima left, the graph would become something like this. So what would that point be? How I decide that point is, that point would be when my difference get reduced to this AR minus AL. So this I am storing in my difference variable. So initially my sum of difference was some D. When this D till it is getting reduced to this diff, which is this difference, this thing, till it is getting reduced to this thing, it would reduce in steps of 2. After this, it would reduce in steps of 1. Okay, I hope that is clear. So this diff variable is storing the absolute difference between AR minus AL. Now, as I discussed, there would be two cases. Okay, like first initial case is if K is already greater than D, then we would print just 0. If sum is less than equal to K, this sum, D is sum here. If sum is less than equal to K, we would print 0. No operations are needed. In 0 operations, it is already there. Already K is greater. Else, either it would be this case where K is greater than equal to difference. My answer would be D minus K by 2. So when K is greater than equal to difference, my answer is sum minus K by 2 seal of that. That's why I'm adding a +1, because if I do sum minus K by 2, this would be floor division. And if when I have to do by 2, then I have to only consider odd and even case. So if I add a +1 and do by 2, I would get a seal of that. So this would be my answer for this case. Otherwise, for this case, my answer would be this thing plus this thing. Here also there would be one small case that we may consider is when this d minus difference becomes odd, then your difference would reduce by 2. Let's say your d is 7 and your difference is 4 and your k is 2. Okay, so d, or in my code it is sum. Okay, so if my initial sum of differences is 7, I need to reduce it to 2. So till 4 I would reduce in steps of 2. So those steps would be 7 minus 4 by 2, the seal of that. So it is 2. So in 2 steps I would reduce this 7 to 5 and 5 to 3. So then I should do 3 minus 2 equal to 1 to get, I would need one more step to reduce this 3 to 2. Okay, but if you do after this, if you do difference minus k, then you would do 4 minus 2 and get 2. So through this formula, you would actually get 2 plus 2, 4. But you should get 2 plus 1, 3 operation. So this odd case only you need to handle. So to handle that, what I am doing is the number of operations I am applying here that I am storing initially is my answer. That would be my minimum answer. So my answer is sum minus difference plus 1 by 2. The seal of sum minus difference by 2, this thing. And then I am reducing my d minus equal to, or my sum minus equal to 2 times my answer. So after these many operations, my sum is reduced to 2 times answer. With every operation, 2 times it is reduced. Now whatever sum I have minus k is we would move in steps of 1. So these many more operations we would have to do to our answer. So that would be my final answer. I hope the code is clear and everything is clear for this problem. So yeah, it was a good problem. And for the easier version, you could have done a brute force thing, like of n into n square into q, anything like it was 30. You could do any approach. So I have directly written the code for harder version. It would be accepted for both the versions. So I hope you enjoyed the session today. Thank you very much for joining.